Oh, this one's tricky. Two right circular cones with vertices facing down as shown in the figure below contain the same amount of liquid. The radii of the tops of the liquid surfaces are 3 centimeters and 6 centimeters. Into each cone is dropped a spherical marble of radius 1 centimeters, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of liquid in the narrow cone to the rise of the liquid in the wide cone? This is actually a really good problem. It's really good. So one way to do this is to be like a heathen and like set values, like make this 4 and make this 1, so that they both have volume 12 pi, I believe. Yeah, if you let the heights be 4 and 1, then the volume will be 12 pi for both. And then when you add, when you add the 4/3 pi from the spherical marble, the volume becomes V prime equals 12 pi plus 4/3 pi, which equals 40 pi over 3. And then since the ratios are maintained, you have like that in the skinny one, it's going to be like 3K to 4K. And then so like 12K cubed pi is equal to 40 pi over 3. And in the fat one, the wide one, you know the proportion, the proportion between the radius and the height is going to be maintained because it's a cone. So once again, 12K cubed pi equals 40 pi over 3. And you might notice something here. Those values of K are the same, which is kind of nice. And it points to a deeper truth, which is that both volumes go up by a factor of V plus 1 over V. And this means that both heights go up by a factor of the cubed root of V plus 1 over V. Because for every factor that you magnify the height, then the radius will be magnified by the same factor, and then so there ends up being 3 times, the factor ends up being cubed. So both of the heights of both cones, when you add in the marble, go up by a factor of cubed root of V plus 1 over V, or actually plus 4/3 pi. But like, as you may notice, the only thing that matters is that it's like the same value. The fact that it's a marble of radius 1 does not matter at all. It could be, you can put any kind of object as long as it like completely submerges. So both heights go up by a factor of this, which means that the ratio of the rises is going to be the same as the ratio of the original heights, because both heights get multiplied by like the same value, like 1.1 or something. And that means that the amount of change is they both change by 1/10 of their previous amount, which means that the ratio of the rises is the ratio of the original heights, which is 4:1, because of like this, 4:1. And that's like the inverse square of the ratio between the radii. Yeah, it's 4:1. It's quite a nice problem.